Archival resource key. These have been around since 2001. They were born at the National Library of Medicine, where I was doing a fellowship from UC Berkeley. And I took them then to the California Digital Library, which is the University of California Office of the President. So they do library services for the 10 campuses, the 3 laboratories, national labs, 5 medical schools, 5 law schools. Basically, it's the second largest public library in the world. So it's a big place. We have 150 disciplines, not just decentralized science, it's decentralized scholarship. Anyway, ARKs have been, I've nursed them along in the margins of my salary. Put the word out, giving a talk, a couple of talks a year, up until about 2018 when I got support at work to actually create an organization. But in that time, 8.2 billion identifiers have shown up, have almost 1,000 institutions that are signed up to mint ARKs. And they mostly libraries, archives, museums, data centers, vendors, but small publishers, especially in the global south, can't afford the fees. I have this one guy in Ecuador saying, we have to use the handle system. And that's $600 a year for our 12 data centers. It's not very much money, but Ecuadorian public tax money, that is a lot of money. So it's like, geez, I'm probably have to do that. So the global south needs a cheaper solution. So scientific and cultural preservation, what does that really mean? It's protecting objects from loss or change. That loss and change is due to all kinds of factors. So it's a wide array of factors. You're also protecting the identifiers, which is direct access. You can say, well, why do you need direct access to things? You can just Google when you want something. Well, actually, it takes months, years, sometimes to track down exactly the things that you want, the collection of things that you want. So it's very important to have direct identifiers. So links that don't break in their cultural heritage institutions, they call those persistent identifiers PIDs. And by 2004, there was traction in the scholarly communications world and the IETF. The IETF is the Internet Standards Body. And the scholarly communications is just basically publishing in libraries and generalized into data publishing, data research publishing. So there were centralized schemes that were basically silos. Perl, Handle, and DOI. Handle and DOI were paywalled. They're decentralized schemes. The URN was the dream of the IETF. Just do URLs and manage them carefully, which is like totally fine. But no one knows that your URLs are meant to be persistent. And then ARK was just like, here's a URL that's meant to be persistent. It's got this little label. And by meant to be, there's no such thing as a guarantee. All it says is that, hey, you query this and you could start to guess, you could figure out if it's persistent or not. And that's the same is true for DOIs and handles too. They break by the thousands and regularly. So there's nothing magic about them. I should mention, historically, there was a proposal for a content addressable scheme called MD5. Remember back when MD5 was a school algorithm? And it was, that was received some attention in the IETF and then it was dropped. I'm not quite sure why, but it would have been dropped because we'll get into that a little bit later. But ARK identifiers is archival resource keys. They're human facing. So these are not kind of blockchain facing, they're not IPFS direct. They're sort of browser ready as URLs. They're clickable. They're prose ready. You can put them in a sentence. They're relatively short. They could be long, but they're meant to be short and citation friendly. I don't know if you've ever seen the 2-column formats in your favorite PDFs.
So we have that issue. So we have content addressed identifiers in the system of those.
Yeah.
But they're so long. So it's like a UID, like a UID for the object, a mutable object. And well, not the immutable object, but that allows us version, right? So we can version, and then we slash the content hash. So we have a URL. It's this small, it's not citation friendly.
Yeah.
And so what we did for it is we set up like a URL shortener service, right, on the blockchain.
So it preserves the fragment.
Yeah, so we have a registry that maps the long content identifier unwieldy URL to the short
Yeah, so
PID.
And I saw that you guys preserve the fragment as well when you, so that you can actually address, I checked out the site when you need access to these ARKs, that fragment is rewritten, correct?
depends on which site you're, so the ARK doesn't really mandate a whole bunch, you can do things different ways.
I see.
But there are different techniques, and some are good practices, and some are not bad practices, and so forth. But there's a whole, I want to write a paper on opaque identifiers, and all the different ins and outs of them. But yeah, long is hard. So basically, opaque identifiers are important because they're, if you want identifiers that age and travel as well, you want them to be opaque, because the non-opaque identifier contains some assertions that look like you could be held to it, the provider could be sued because, hey, we can tell when this was minted, we can tell this is supposed to say this, and it's, it's at odds, there are political conflicts, there are infringement, trademark conflicts, so opaque identifiers are great for longevity and for language, resolving language problems, where there is no detectable language. But they're just a pain in the ass to use for human beings, because as a human being, you can often detect spelling problems. So with opaque identifiers, you tend to want to, add like a check character. And you've got transcription problems where copying and pasting these huge things, and then the formatting requirements. So basically, it starts to hurt for a while, and you eventually come up with something that may or may not be lexically related to the original long address. But if you can work on something clever, that's great. I could geek out about that for a while. Anyway, ARKs, they look like what's on the screen. The internal ARK label says what it is. It says it might be good for long-term reference. You can't look at something and say it is, it might be good. So you should be able to query it. So it's also inflectable. The idea is that, hey, we've got all these related things, commonly related to an object, it's its metadata. Why should you invent a whole new string for that? Why not just add an inflection on the end and say, like a question mark? So we invented this question mark a long time ago, so people complain because it doesn't make it through load balancers. Anyway, so question mark or question mark info lets you query it for metadata or for a persistence statement, which is really important because the ARKs recognize that there are different flavors of persistence. All right, so that's a little dive into geekery. So people talk about persistence, but they rarely define it. We know when persistence is not happening, like, oh, a 404 not found, that means it didn't happen. And we also know, and hey, that's the wrong bit stream. That doesn't match, right, my content ID. It's much harder to prove when persistence is occurring, and especially if it's occurring in the presence of change, which is normal. Presence of change, which is normal. Preservation is not the same thing as unchanging content. It is at that sort of computational level. The content addresses give you this amazing, fantastic leverage, right? You can detect bitstream changes, but really valuable information that people are curating. People, imagine your paper, your software, tinker with it endlessly. You cluster objects, you package objects with it. There's a cluster of things. There's provenance statements, there's policy statements, there's permissions, there are licenses that go with things. There are version, change histories and annotations, and it's not just a linear list that you get. Now we can have an IPNS name for that version change. It's not that simple. So this is what my experience is from the cultural heritage side of things, and it's possible to say, oh, that's kind of a boutique kind of thing. It's never going to scale, and that's true. It's sort of true, but there's a hell of a lot of money going into like the Peabody Museum and the museums in this part of the world, people care, when people care about stuff, they tinker with it. So there's constant change. Another huge thing is that technology is driving a lot of the change. It's driving a lot of user expectations. So that book scan that's got into the archive 10 years ago, well, the OCR algorithms have improved a lot. So the OCR, if you go back and revisit it 10 years later, the OCR is going to change. And you're not going to complain too much, probably. You might if you were depending on that because a treaty was signed. But in most cases, you're not. So there's a preservation with change as a good thing. And you just have to be careful when you're talking about persistence. What kind do you mean? So it's not binary. Persistence is not binary. So science, you've got like Earth observation, you've got these sensor files, and every 6 seconds a whole new data dump gets appended to it. Stuff before it didn't change. You've got persistence there, but it's growing all the time. You've got questions about how often do you snapshot it? How often do you let every single version be available? There's a similar model to simple journals. Here's a journal, but new issues keep getting added to it. What's going on? It's changing. Well, it's preserved, but it's changing. Yes, and it's a feature that it's changing. And abstracts change regularly because authors get upset when there are typos. So egos are in there. People get upset when the dosage is wrong on midline in the abstract, or because someone could die if the dosage is wrong. But preservation was supposed to be happening. All right, so think about scholarly literature is a little bit like software, right? You've got Ubuntu, you've got long-term stable distributions. That doesn't mean they don't change. They do get security patches, bug fixes, right? That's a feature. But it does affect reproducibility of science. So, gosh, we're going to think about this. What does that mean? So, it's not simple, unfortunately. So, you've got all these valuable objects that are often complicated and volatile, and human curated. And I don't know what this means. You've got, this beautiful theory around Merkle bag trees and cryptographically sound hierarchies, but I don't know what it means when you have lots of change. How often do you keep these and where? So there's a practical side of this, which we should keep in mind. And then what do you mean by persistence? It's like, what do you in fact mean with your institution, with that collection and that particular object? We find that you should be able to say different things. So we wrote this paper. It proposes a bunch of vocabulary for describing these things. So I won't get into this further. I said that ARKs are decentralized, but they're not decentralized in the same way that DeSci is normally thought of, right? It's not peer-to-peer. Human beings are inherently centralized. It's me, it's all about me, it's my computer, it's my laptop, my browser. There are centralized PIDs that, that sort of the Perl URL, DOI, and these are host name dependent. There's one of those hosts. There are decentralized PIDs that are like with many host names. So ARKs, you can host the same ARK at many different host names. So that's a kind of decentralization. That distinguishes it from the others. But it's certainly not content address. It's not a peer-to-peer CID. Think about DNS. DNS is distributed, but you just got one interface to it. And you kind of ask for it, hey DNS, who are you asking? You're asking, there's sort of a wrapper around something that gets to a set of root nodes. There's an IPFS. When you ask IPFS, what are you getting to? Beneath, under this, under the hood, something's happening. But your experience of it is fairly centralized. So I'm just going to qualify what I mean by decentralized. So looking a little more closely at the ARK, it's a labeled URL with a globally unique identity inside it. So it really comes after the host name. So the label is the ARK colon. After that comes this, basically it's kind of like analogous to the publisher ID. It's the name assigning authority notice, who originally assigned it. They may have no relationship to it. In fact, general law will have no relationship to it long term. The host name makes the ARK actionable in today's internet environment. But the core global unique identifier is independent of the host name, it's even independent of the protocol. So the idea is that these the host name is kind of like this booster rocket. It can drop away and can still have persistence after that. So who is using ARKs? Well, libraries, I mentioned, data centers, archives, museums. We've got government agencies, small publishers, a bunch of educational institutions, small vendors. There are examples. We've had quite a bit of growth, as you could see, pretty accelerated. They're all over the world. Kinds of things that ARKs are used for, by far the biggest that we know of, and this because when I say that we know of, because it's decentralized and we don't know everything. One of the things we want to build is a counting ARKs project. Let people tell us how many ARKs they have, so we have better numbers. So genealogical records at Family Search, they're huge. Portico is a source code file for all published content. Literally all. They have maybe 40 billion ARKs, but they only think that 100 million of them are really interesting to the rest of us. But they have a mammoth dark archive, which there are trigger events which turn it like a publisher with that business. So Internet Archive's been scanning, you got 30 million ARKs from the scanned books. The French National Library, the DNF, was a major early adopter and they influenced adoption across France. The Louvre Museum is in there. So Mona Lisa has an ARK. So does this, there's a picture of an ARK that has an ARK from the DNF's collection. But ARKs can be assigned to anything. So vocabulary terms, physical objects, digital objects. So here's a sort of a cheeky slide. When I say cheeky, I used to work for the University of California. I stopped in July, and we did DOIs and ARKs, and I had to be a little bit restrained in some of my comments. I can be a little less restrained. So this is cheeky then. Basically, none of these persistent identifier schemes do anything for you. Let's just say right up front, they don't do anything for you. They can get in your way. And they can cost you money that you could be spending on preservation. So let's look at the bottom half of that. So you've got decentralized administration, you've got flexible metadata, you have persistent statements built in. You can extend your identifiers during resolution. You can't do this with a handler DOI. You can't add anything. You can't put a suffix on the end of your resolution. Just really. Well, our resolver is, you can use any resolver you want. You can build your own. Most people do. You can use our global resolver, which is N2T. And N2T does all sorts of fancy suffix pass-through things. You can register one identifier and manage millions of them. Anyway, but the bottom line here is free, non-paywalled identifiers in unlimited numbers. No one should have to pay for the right to create persistent identifiers. Another quick glance into the details, if you want to, a little more anatomy. You've got name assigning authority on the left. You've got assigned name on the right, and you've got various subparts. The slash and the period are reserved, and they have meanings that intuitively you think of when you think of a URL. Right? The dot indicates variance, slash indicates a kind of hierarchy and inclusion, and that's it. So opaque strings, they can come from anywhere, any source you want. It could be a simple counter, UUIDs, produce content digest if you wanted to. We have the software called NOID, nice opaque identifiers, which keep check characters, which make you able to detect the most common transcription errors. So the ARK Alliance is arcs.org. So as I mentioned, from 2000 to 2018, ARCS was done in the margins of myself. A couple of talks a year. We implemented it at the University of California. It grew slowly in the early years, as you can see on the graph. 2018, the French National Library said we need to have an ARCS summit because there's so many users in ARC all over France. And we had a wonderful event there. I had to get up on my hind legs and speak in French for 45 minutes, which I did with a lot of help. And in 2019, University of California and Doors Space worked together to create this community, just to try to move it from being so dependent on the University of California to being dependent on more. So we have 4 working groups. We have 4 working groups, and we're looking at, we talked early on about sustainability. And every conversation we had about sustainability took us to the same cliff edge that everyone else has faced, which is in the digital preservation communities, there are all these really famous belly flops where you have a digital preservation network, DEEPIN. They launched and they said, we're going to be forever charging only Ivy League institutions $30,000 a year. And they didn't make their value proposition clear. 8 years later, people started unsubscribing and fell apart. Everything fell on the floor, just complete failure. We didn't want to do that. So we kept working and driving our costs to zero. It's all volunteer right now, but we still feel like we've got a registry of institutions. We have a PIN resolver that just redirects to your local resolver. It needs a little bit of tending. We're figuring out a way we can do parasites on GitHub to do metadata delivery, figuring out the way we can, free hosting. We don't need that much storage, but we will eventually for this when namespace is split, which is the kind of system can't manage very well. Anyway, if you can get, if you want to get started, here's how you do it. Follow us on Twitter. Final slide is, we've covered much of this stuff. Our infrastructure is the community, the resolver, the registry of ARC organizations, and we probably need a few staff positions, just like, half-time person to monitor the resolver, registry, the working groups which are managing the registry. And, this is amongst all problems that metadata is the biggest pain in the ass for every project on the planet. And I have an answer, I have a whole other talk for that. And the answers, all the answers come in the report. But we could also use another face-to-face meeting. The ARC Summit in Paris is fantastic, but we need someone to help organize that. So basically, I'm thinking, great to have a little endowment, throws out some interest, and interest never go into the principal, the interest just fund some staff to keep this thing going. That's what I'm looking for. I'm not looking for astronomical growth. Questions? I have 2 stickers, 2 laptop stickers, like this. That's the alpha version of sticker. That's how. Questions?
Yeah, I mean that's so it's great. I'd love to keep in touch with you and exchange, because we're also in this process of thinking how could we create better persistent identifiers that allow us to address the entire linked data structure of a research object that is versionable, that is both that essentially uses content addressed, right? Content addressed, and also allows us to create a short permanent identifier, right? So that's something we're thinking very, very hard about these problems, but we don't have the experience, that background in that domain, that's would be something fantastic to like think about and collaborate on.
Absolutely. And I have ideas on that. And,
Stories from the field.
Yeah.
That's what I want to hear.
oh, okay, funny story. Yeah. So it's what the versions or numbers are for, like what you see on the end of these periods, like .v1, .v2.
Same thing running.
Right? I mean, that's the obvious way to do it.
Yeah.
How would you do it? Well, maybe I'd do it that way.
I like the question mark .info, because we also want to be able to resolve that, so it resolves the metadata, right? So we have this JSON LD self-describing data model, and there needs to be a way, if you're a machine and you're crawling these things, the machines need to be able to like resolve like metadata.
So the way IPFS, I think, does it, they do question mark raw.
Well, so question marks are a little bit problematic. Back in the day, it's like, hey, question mark by itself is not reserved. Let's reserve it. It's got it now. It's actually undefined. It's an query string in HTTP. And so what happened? Is, things are going wrong. Java libraries, they couldn't recognize that. They just couldn't do it. So you had to like help them with like put an Apache front end on the Tomcat, and then you convert it to something else. So we're seeing some pushback from people saying, you could maybe support the question mark at your global resolver for human beings to type in, but we need to convert that to something like more standard API type of, the fast APIs, jam some kind of path-name component in front of it, like metadata slide article, so that it arrives to APIs without getting mangled by a load balancer, because they can strip off, but they can do funny things with query stuff. So that's like, the dust is not quite settled on that, so we may have something to say about how to do that with us. But I'd love to talk to you about that, get your requirements. Yeah.
So how do you, sorry.
Just your hand was up.
That's
So then
okay. I mean, whatever. I work at Protocol Labs. We work on IPFS and Filecoin. I'd just love to hear if you've done any investigation of that. If we could potentially help you in some way by, offering storage or becoming an ARK, organization. You tell me.
you could certainly become that. It's free. I've dabbled in IPFS just enough to be dangerous, probably, and spout something wrong.
On the last slide, you said you had a bunch of things. Is there a URL or any place that we can go, or is it just?
Yeah. Let's see.
Oh, ARK.org.
Yeah.
Okay.
So in front of you, there was another question?
Yeah, could you go back to the slide you were at before with the entire URL? So how do you resolve who is updating of a version of some kind of a document or a file?
Well, from the high level, in this case, example.org, it's like the BNF.fr is the French National Library. They publish all their ARKs with BNF.fr. So an ARK that shows up, they're providing it. So the answer to that question is not going to be baked into the ARK. You're going to start by looking at the French National Library. Now, if you, still completely not hammered out, is like, what should you get back when you do metadata? What's the standard format? And this is the devil for many projects. It would be nice if the metadata came back with a statement about who, that would answer that kind of question more fully or more reliably.
So every institution basically would define or decide, they would effectively be the gatekeeper for who gets to update this document.
Yeah.
Okay.
Oh, absolutely. Yeah. So a bunch of the certainty and guarantees that you can get with IPFS and content IDs is not visible to the ARK system. So it's substrate somewhere in there, and then that could bubble up into a persistence promise or assurance, but it's not visible to the ARK system.
And so how would you resolve is there any time stamping, or would that go in the metadata? Like, how would you resolve, for example, if somebody, there's a disagreement in, let's say, like an open source community, and there's some file, and somebody says, I want to update it to change it, and people say no within that group, or the institution says no, and they say, okay, I'm going to go to another institution, and I'm going to go to another ARK institution, and I'm going to go file it there. How would that be resolved? Is it through timestamps, or like just have different versions like GitHub, or?
Yeah, it's not been codified. So a great place to start would be to say metadata should return that with which you can make those, take it to the next step. There is a problem with human-oriented systems that two archives that maintain the same archival object, even with the same identifier, they're bound to diverge, which is just a terrible thing to say. Sorry, I have to admit that. They're bound to diverge. That happens. That's, that happens with different publishers, the same PDF, it's decorated with different metadata. Catalog records with the same book, different libraries, with 60 different catalog records. It's a dirty secret.
Oh, the metadata in science is awful.
Yeah.
Right,
Yeah.
awful. You go on Crossref, you pull metadata, so we started
Yeah, I
with
tried
this-
that for a long time.
You can't just go Google Scholar and get that.
We were like, well,
And that's just beta check it. It's so easy, bro.
yeah, we were like, we don't need to reinvent the wheel, let's just ask the metadata from Crossref, and then we autofill it, and you're like,
every publisher has their own kind of unique flavor. Right?
Yeah,
And that's the
yeah.
tough part.
and there's all missing holes and like all sorts of problems, and it's essentially, it's unworkable nearly, right?
Yeah,
We did, as much as we could.
Yeah. We might just amend this whole thing of pulling Crossref. It's so bad.
I think it's so valuable.
Is there I have another question also. So you also had the list of things that this can and can't do with the checks and the X's. Is there something that isn't on here besides? I mean, besides the beginning ones that you said were kind of jokes.
Yeah.
Is there something that you think would be desirable that could be done with a PID protocol that ARKs can't do?
If there were, it's on my to-do list,
Okay.
because I'm the one thinking about this. It's if there, if there's something that is feasible, I'm probably thinking about it. There's all kinds of stuff that's still not here. Like every single one of these, has it been around it long enough, and people start to think, oh, it's guaranteed, it's got an ARK, it's guaranteed. That's not. So there's a one line here is pixie dust. All of these have pixie dust. It's like magic. People think there's some kind of, just by giving it one of these names, you doubt it with some magic. And that's just human psychology. So I'd like to try to weaken that association, but and that's just one thing. Metadata is the huge nut, and so we're trying to put out a sort of a formal-ish standard like IETF and ISO for ARKs. It's been in the incubating for 18 years or so, and it's going to get to the point where the hard work that follows it will have to take place online. But often there's a piece of paper that lets a government agency go forward with a contract, without which they can't go forward. They need a piece of paper. So there's kind of like no living standard is fixed, no real standard is fixed. It's like out of date as soon as you publish it. So the hard work is going to be nailing down sort of the metadata is done kind of defined by example. So that's, I mentioned there's really important work to do with metadata. And I know because I was through the metadata wars, I mentioned Dublin Core. So Dublin Core was this great idea, 15 elements. It's a standard so small it won't register on a vacuum scale compared to the old library standards, which were like 2,000 MARC records, 3 binders. So that was the idea, and it's very appealing, and you can sell it to anybody, except you give it to the catalogers, and they don't you don't even know how to start. It's 15 elements, like name, creator, title, author, date, format. And you give it to a cataloger, they don't even know where to begin. They start to diverge right away. Really big. So I had some answers to that. That's 15 elements is too many, and none of them are required. So therefore, this glass of water is Dublin Core compliant because it has no elements. So anyway, I created this thing called Dublin kernel, which is 4 elements. And then I created this sort of Dublin mantle, which is like, hey, this should be this crowdsourced meritocracy, kind of like Stack Overflow. Everybody contributes a term and you upvote terms of reputation-based voting, and et cetera. And basically, because there's so many more elements that we need. And I can tell you the reasons why that didn't work. Anyway, that's really, metadata is super important. We need to get some traction.
Yeah, so it's an interesting thing. When we were thinking about it, is, when a researcher uploads his manuscript, we go through the manuscript, we extract all of the text, we generate metadata, right? So we essentially pre-populate the fields. And one of the things we're super excited about is using machine learning approach to standardize metadata. I'll give you an example. There's this big problem right now, which is ideally for machine actionability, you want to have ontologies and controlled vocabularies that allow, some degree of interoperability between, these preserved records and research artifacts. And one of the things that we're very excited about is some people have started working on automated classifiers to essentially automatically generate that terms from an ontology to accompany a piece of research, right?
Yeah.
So this idea of like not having any humans in the loop for entering metadata and doing as much as is machine possible, right? With a method to auto-generate that could go a long way, right? In promoting having higher quality metadata, standardizing it, and creating interoperability.
Yeah, it could. Humans are really picky about their terminology. So we do have this crowdsourced metadata vocabulary builder, and we got this group of citizen scientists to use it. We put the persistence vocabulary in there. We got a group of global cryosphere with snow and ice data center people. And here's a narrow domain of Earth science, just Earth science, a narrow domain within Earth science, and they have 16 different definitions for the word glacier. Right? They can't agree. Jesus, maybe we should use machine learning. Or this is good enough. And it tells them maybe it's sufficient that it wasn't one of the 16 choices, it was another one. They don't have to lose in the ego. But I don't know. Maybe that's going to help.
Yeah, lurking on these metadata forums and platforms, you see, how much people fight over like defining the terms of the actual vocabularies and looking through the history of OL, for example, right? This OWL ontology.
Yeah.
It's just oh dear.
Oh god, yeah.
And it's funny because a lot of these groups that are creating these metadata standards, like especially for ontologies, where ontologies shine is in domain specific kind of context. But generally what I've seen is these working groups are not belonging to any particular domain. They're trying to create something a bit more general. And I feel like that ends up being kind of like a trap. You know what I mean? Because you end up trying to build a framework for everything without particularly going deep into one field where I think then you'll have more nuanced conversation in that field.
Yeah. Well, I have a paper what I want to write. It's something like there's no such thing as all real metadata is project level. The scientists are wherever they're going, they're pushing they're pushing the boundaries. The models are every model is broken, right? Some models are useful. Someone said that. And so they're all pushing up against some model, and the real keen observers are always, their ontology is going to be a little different from the standards. So they're going to be recording observations in spreadsheets, or if they're doing it by hand or wherever they're doing biomedical stuff. and they're gonna be puzzling, this doesn't quite fit, and there's a good reason for that, and that's gonna lead to a breakthrough. So we need ontologies that permit breakthroughs, permit stretching models, right? And so I think admitting that all real metadata is project level, it's really, it's not even institutional level, it's project level. And then what you need right next to it is, you know, we're supposed to use, we were told to use this domain vocabulary, and we're deviating in this way. So the right over my shoulder is this thing that I'm supposed to be using, and it's tied closely to this. So that gives you your best chance of crosswalking, because you need more general ontologies so that you can crosswalk, and that other people can find your stuff who don't know what language. So I think it's a question of helping your crosswalkers.
What's your opinion on scheme.org?
I know some of the folks there. It's another human-oriented, you know, the experts argue, they come up with something, I don't know how it's done. I can't say it's bad. I can say it feels like it would feel nicer if there was like a sense of, more sense of ownership, that we could have a voice in it. It's very influential, but it would be really nice that, you know, the way standards are, I mean, I was in the development coordinators, and I wrote up the consensus. After 11 months, we had the same basic terms that we had after 5 years. So everyone was just sick of it. So we said, let's just standardize. Let's just call it quits. But it's a bunch of egos. It's a bunch of experts getting in the room. This is hundreds of thousands of ontology groups are meeting, they're flying across the world, they're doing email during the meetings. They just want it to be over. Some of them haven't really been practitioners for a while. Nobody tests this stuff before it's published. If you have this thing that I've been working on with this Drexel Metadata Research Center, they are we're working on something that you can test directly, and you upload and download it with reputation like Stack Overflow algorithms. The idea is like let people vote, and so before it's standardized, right? And then consider it fungible. Like we've got this vernacular. It's the schoolyard evolving vernacular. And if it's stable and consensus is reached, then it becomes canonical. So it's stable, depending on your risk tolerance, you can quote, you know,